All right, homework should be out, and let's take a look. Let me go grab homework first.
Yeah, we're not fantasizing over that. I do not remember what you posted on your story.
Okay, come back out to use old homework. Grab yours, pass off.
You was not throwing up.
33.
Sometimes it gets out of hand.
Yeah, I told you. Come on.
Questions off of 33, 34? Yeah. 19. And it was 33, 34, right? Okay.
Yeah.
Number 19. Ooh, okay. Number 19. It got. So there's not 3 terms to it, right? It just has 2. So we need to kind of look at this, and you can do this any number of ways. You could realize 25 is 5 times 5, x, x, y, y. And 15 is 3 times 5, x, and then 3 y's. And then when we look at it, it's like, okay, I have a 5 and a 5. So 5 comes out. I have an x and an x. So an x comes out. I have 2 y's and 2 y's. So a y squared comes out. And then I'm left with here 5 and an x. And here I'm left with a 3 and a y. And that's all you had to do. What else did you see on the homework? Yeah?
21.
2-1?
22.
Yeah, we don't need to worry about 22, 23. Not too stressed about those. All right, so which way would you like me to do it? Logic or the Cherry Creek method? It's your choice. You got it. All right, so I'm going to multiply that and that together to get me a positive 12. But remember, to get a positive number, it's positive times positive or negative times negative. So which one would make sense?
Negative.
Both being negative. Now I need the factors of 12 that add up to 7. So I got 1 and 12, 2 and 6, 3 and 4. Which of those both, if they were both negative, would add up to negative 7? 3 and 4. Those are both negative. So then I have 2x squared minus 3x minus 4x plus 6. Take a look at what we have in common here. That negative comes down. I have a 2 here. And then I have 2x minus 3 in common between those. Done. Yay. Good.
What is
17? Ooh. Can I move off that one, or you're still on it? You're still writing? You're good? Still writing?
Yeah.
Good. And it was 17? Yeah. Right. Good, good, good. Yay. 17. Okay, sometimes there's going to be just a greatest common factor. Sometimes it'll factor even further than that. So let's break things down. So 8's the same thing as 2 times 2 times 2, x, x, x. And then 28 is 2 times 2 times 7, x, x. And then 24 is 2 times 12. 12 is 2 times 6. Did I do all those right? So let's just verify. 2 times 2 times 2 is 8. X times x times x, x to the third. 2 times 2 is 4 times 7 is 28. And then x times x squared. And then 2 times 2 times 2 is 8. Times 3 is 24. And then x. Cool. So those are the prime components. And sometimes that's an easier way to look at the problem. So I can factor out, looks like 2 2's of each of those. So 2 times 2 is 4, right? Can I factor out any more numbers? Being I have a 2, a 7, and a 2, and a 3.
No.
Nope, they all don't share the same thing. The maximum x's are a singleton x. So I factor 4x out. And then this is 2x squared minus 7x plus 6x. Hey, isn't this here, this here? Are they the same? 2x squared minus 7x plus 6. 2x squared minus 7x. Oh, I forgot. That x isn't supposed to be there. So I factored out the x. Isn't this the same right here as that last problem?
Sure.
Look, I mean, it says 2x squared minus 7x plus 6. So can I factor that? Sure. So I get 4x, 2x minus 3, x minus 2. So that is kind of a bigger one to be factored out. So you have a greatest common factor to factor out, and then factor out the Cherry Creek method. What else? Yeah.
15.
1, 5. I have 5x squared minus 5x minus 2. So my magical number will be negative 10. In order to get a negative, I have to have positive, negative. Factors of 10 are 1 and 10 and 2 and 5. Does it look like I can blend any of those numbers together, whether one's positive, one's negative, to add up to negative 5? If I combine the 1 and the 10, if one's positive, one's negative, I either get an answer of positive 9 or negative 9, so that's not negative 5. If I do the same thing to the 2 and the 5, make one positive, one negative, I either get positive 3 or negative 3. Are there any other factors of 10 I should think about? So this one won't factor.
Don't you just say prime or something?
Yep, so I would use the word prime. And we do have a quiz coming up. Let's see, when is the quiz? Thursday. And there's probably one question that will be prime. Every year, I get that kid who's going to get the one problem right. And they're the kid who's turning it in after 3 minutes because they wrote prime on every problem. Even though I said, there's one. And they're like, dude, I got one right. Yeah, you got a 1 out of 26. You're real smart, aren't you? So please don't be that kid. So I will warn you that one of them will be prime, all right? You know, when I go do the answer key, I will let you know how many are prime. And if you list prime all the way through, I'll just say, shame on you. What else? Anything else from last night's homework? This weekend's homework?
Can you do 6?
Number 6, yeah. Number 6, we're just going to multiply it back together, but we have to understand what a few of the things are that we have. I have 2 of these that I'm multiplying, so I have a negative, x minus 2, x minus 2, plus 3. Is that okay so far? Do you find that okay? Okay. We could just double FOIL that out, keep that negative there. Is that okay? Good. Combine like terms. Is that okay? I ran out of room. Oops, come on. So then I'm going to distribute that negative. Combine those like terms. Done. Anything else you'd like to see? Yup.
22.
Is that one of the word problems?
Yeah.
Skip it. Skip 22 and 23. Don't worry about them.
I tried to do them.
Cool. Don't worry about them. You're good. We're good? Sophia, question? No? All okay? All right, if you would, pass up 33, 34, right?
It's just you should give me some extra credit.
For what?
About the word problems.
Okay, you got it. Extra credit for all four.
That,
Four.
Did you grade this?
There's, yeah, I got 4 on there. Kind of hid it amongst your numbers. Sorry, let me poke you with that. Ooh, did you see those cat-like reflexes? Got lucky. There's 3, I think. 4. All right. So we're going to take a look at just the next steps, and we've already kind of gone through quite a few of them. All right, so a few of you have started seeing that some of them can't be factored, so we list the word prime. A few things that we're starting to get to where you should start seeing is what happens when I graph. And we're not graphing for quite a while, so don't let this panic you. There's actually 6 different things that can take place when we graph on the XY axis. Okay? When it's x squared, it looks like something like this. So it started from the top and it ends at the top. If it crosses here and here, if those are fractions and decimals or whole numbers that are rational numbers, meaning they can all be written as fractions, this would allow us to factor. But sometimes you might get one that looks like this, comes down and kisses it once. Okay? And this would be like if factored, we had this. You get the exact same number twice. It's called the double root. And then sometimes it won't factor just for the sake of it's not crossing the x-axis. Okay? So this has no real solutions. And when you say the word real, we're going to capitalize it because we're talking about the real number system. It's the name of that number system. The other last 3 things that can happen is you can have this take place, and even this take place. And that just means that my x squared value was negative. So we're not we're not taking these yet to graph, but we will eventually get there. But I just want you to start seeing why are certain patterns taking place with these. And sometimes if we can factor it, that means we can tell exactly where it crosses the x-axis. Sometimes if you can't factor it, it might still cross the x-axis, but we don't know exactly where, because it might cross at like square root of 3 or 2.77, huge fraction forever. Sometimes it comes down or comes up and kisses it once. Sometimes it won't cross the x-axis at all. So the x-axis is what determines for you what these are doing. Okay? All right, so as you started seeing some of the homework, sometimes we have a greatest common factor. So take a look at 12x squared minus 4x minus 8. Is there a number that goes into all 3 of those terms? If so, what do you think it is? 4. Someone said 2. So 2 definitely does. Does 4 go into all 3 of them? 4 goes into 12, 4 goes into 4, 4 goes into 8. Not like that. So 4 is the greatest common factor. So on this one, if I factor a 4 out, I'm left with a 3x squared. Now let me pause there. Do you agree with that? Is 4 times 3x squared 12x squared? Yes or no? And then the next term. If I factor a 4 out of negative 4x, what do I have left? Just negative x. If I factor a 4 out of negative 8, what do I have left?
4. Negative 4.
2. Because 4 times 2 is 8, right? So that looks like it's nice. Yeah?
Wait, so are you just saying like 12 divided by 4 and negative 4 divided by 4?
Mm-hmm. So then we have to think, can we factor this still? And things that we'll have to know is that 4 has to come down. That 4 is right there. It's the greatest common factor. It's part of your answer. But then you have to take a look. Okay, if I multiply these together, I get to negative 6. In order to get to a negative number by multiplying, I have to have a positive and negative number. Agree? What factors of 6, one being positive, one being negative, would add to negative 1? Oh, cool. I'll grab the back seat and I'll get it for a second. What factors of negative 6, one being positive, one being negative, add up to negative 1? 1 times 6, will those work? What's another factor of 6? 2 times 3. If one of those is positive and one of those is negative, will we get negative 1? What will we get right there? 2 and 3, which one's positive? 2 and 3. If I flip-flopped it, it'd be a positive one. So, all right, so let's factor that out. I get 3x squared plus 2x minus 3x minus 2. What do I have in common here? Just an x. So that gives me 3x plus 2. That sign has to come down, so I'm factoring negative 1 out. 3x plus 2. So then my answer is 4, 3x plus 2, and x minus 1. So this whole thing is my answer. If I have to factor out a greatest common factor, then that should work for us. Here, all right, taking a look at the next problem. See if you can do it the same way. Did you need to finish the white part too?
No, I think so.
That was good? Okay, there you go.
Thank you.
Yeah, boy.
No calculator on that part that you're doing. Unless you have 4 function.
What'd you decide? What's the biggest number that I can take out of 4x squared, 20x, and 10? Yeah.
20.
20, I can take a 20 out of 4?
No, you can only take 2.
2?
2.
2? Sound good?
Yeah.
4 won't work? But 4 works on the 4 and the 20.
There it is.
Yeah, but it doesn't work on the 10. So the 2 is the largest number I can take out of all those. What is that, 10x plus 5? Is that right? And let's try to see if we can factor it. So I'm going to multiply this times this. So I get a positive 10. All signs are positive, so all signs have to be positive. So what numbers, both being positive, when I add them together, gives me 10?
2 times 5.
No, when added together.
1. Okay.
None of them.
Yeah. If they're both positive, I add them together, I get either 11x or 7x. Agree? So this is your answer. This is as factored as you can get on this problem. Okay? So sometimes you can just take a greatest common factor out and that's it, and you have to stop there. There's not much more you can do. May I move to the next slide?
Yes.
And then sometimes they have only 2 terms. So what does it appear that I could factor out of 8 and 10? 2. What about x squared and x? X. So I can factor 2x out. That leaves me 4x plus 5. I can't go any further than that. It's done. It's factored. Is that okay? Am I done? Is there more? 2 more? All right. What about this one? I have an 18x squared plus 3x plus 2. Well, nothing's going to factor out, so my magical number is 2 times 18, which is 36. And because all my signs are positive here, I have to have positive, positive. The factors of 1 and 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Any of those add together to give me 3?
Yeah.
1 and 36, 37, 2 and 18 is 20, 3 and 12 adds together to 15, 4 and 9 gives me 13, and 6 and 6 gives me 12. So I can't get that middle term, agree? So all we need to write on this one for right now is prime. It's not going to factor. See how I kind of logically went through that? And this is the one last one. Oh, okay. So remember, double distributed is all we're doing on this one is we're just putting it back together. And then like terms. That's all that is. This one, I just have to distribute 10 over. So I was just trying to give you some ideas of what might come across and then combine any like terms. What about this last one here? What do you think we should do?
13x.
Yeah, distribute 13 here and here. Agree? That's 26. And then distribute 2 here. What should we do at that last part? Put like terms together?
Yeah.
So 13x and 2x is 15x plus 32. Done. Good? All right. We got some time. I want us to work on, in the next 5 minutes, the odds. Okay, 6 minutes. See if you can figure these out. See if you can walk through them. If you're sitting there just staring at them nonstop and you're doing nothing at home ever on trying to go back over math, that might be a clear indication that you're not preparing yourself. So just try the odds in 35. We'll do more, so that's 7 questions, 7 minutes. So again, just hit the odds. See the best you can do on it.
Is this what we just did?
Yeah.
Oh, okay. Negative 2, -8 would be negative 10 then add.
And negative 10, 2 times negative 8 is positive 16. So that's the way to go. If you're stuck on number 1, I'll have it worked out for you up here. There's the answer to number 1 if you got stuck. Number 2 worked out. Get it? Thanks, buddy.
What do you think?
Agree? And I know it looks easy when I do it because I'm the teacher. Some of you are staring at those for a long time. What are you not seeing? Are you not seeing the factors? Do you not know how to do the factors? If not, you gotta have a calculator out doing it. You just go, 42 is divided by 2 is, oh, that's 21. 42 divided by 3, that's 14. What's that?
I forgot the 3 times.
3 and 14. That's a tougher one sometimes. But again, have a calculator out when you're doing it. Don't sit there and say, oh, I never learned how to figure out the factors and act like that's your handicap. You're not going to do it. Get a calculator out and figure it out. 42 divided by a number is not hard to do. It doesn't come out a whole number. Guess what? It's not a factor. Yeah.
I just don't understand where 3 and 14 like come into place.
So 3 times 14 is 42. So I multiply the last number and the first number together every time. If it's just an x squared, that first number is a 1. So like back on this last problem, my first number here is a 1. So 16 times 1 is where that 16 came from. So it's the exact same iteration every time. It's not, I'm not changing it saying, oh, because we're using the letter x on this, I'm going to take the middle number, square it, and then add 4 to it. I'm going the first times the last, whatever that number comes out to, I'm looking for the factors of it. The factors of that number that result in that, when I add or subtract them, is what I'm looking for. It's the exact same pattern, each and every time. So watch. So let's do the exact same pattern. That's a 1, right? So 45 times 1 is 45, right? Now we have to use logic. If I'm multiplying two numbers together, they can both be positive to give me a positive, or they can both be negative to give me a positive, correct? What do you think this one would be? Both positive or both negative?
Negative.
Why is that?
Because it's negative 18.
Yeah, because that's a good key. So then the factors 14 are this, or 45, excuse me. And then, let's see, 3 and 15, doesn't that work? And then 5 and 9, that works. So of those being both negative, when I add them together,
3 and 15.
right, if I add the 1 and 45, both negative, I get negative 46. This gives me a negative 18, this gives me negative 14, right? Oops. Because I factored a negative out, that changes that sign. And then
Wait, but where's the 45 go? Because you did x minus 3.
So I broke it down. I look at each. I factor negative 15 out here. It's negative 15 times negative 3 is positive 45. I took it out as a factor. Last one, or one more, two more. All right, so this one. What's my magic number? Help me out.
10.
10, and it's positive 10. So are both of my terms positive, or are they both negative? And how do we know?
Wait, I have a question. Didn't you say that all the numbers have to go into one number?
Back me up a little bit. Where are we at?
So like you said with this, you said like it had to go into all numbers. So you have to find a number that went into all of those.
If we have a greatest common factor, yes. These happen to not. I can't factor a
How do you
2.
know if it has greatest common factor?
Well, like 2 doesn't go into 11 evenly. Give me a whole number.
Okay. So if it's like 10, 4, and 8, like there's one number that goes into all of those. It's 2. So if all the numbers go into each other, then it's greatest.
If there's a factor, so sometimes it can be a 2, sometimes it can be 4, 3. You're just breaking the numbers down.
Okay.
So both positive, both negative.
Both negative.
Both negative, like it. And then 1 and 10, that's as far as I need to go. I don't have to worry about the 2 and 5. Why is that? Well, when I add those up, both being negative, it gets me the 11, right? What can I factor out of both those? 5, good. And remember that sign switches because I factored out the negative. As long as those are both the same, it's factored. As long as I have that and that in common. Cool. Last one? Or 2 more?
2 more.
Okay, this one has a greatest common factor. How do I know? This one has the greatest common factor. That is a letter and also a number. How do I know?
Because they all go into 2.
Yeah, so 2 goes into all of them, so I can factor a 2 out of all 3 of them. What else can I factor out of all 3 of them? An x. So if I factor a 2x out of 2x to the third, that leaves me x squared. How do I know that? Well, I know that 2x times x squared is 2x to the third. Yes?
Or 2 divided by 2.
Plus 2x times what number gives me 14x squared?
7x.
Yeah, 7x. And 2x times what gives me 20x? 10. So this 2x has to be part of the answer down here. Okay, I don't need to do it yet. Hey, can I do this one logically?
Sure.
Yeah.
What do you think it factors to? X plus 2, x plus 5. See the pattern? Do you agree with that? If I multiply it out, I get x times x, x squared. X times 5, 5x. 2 times x, 2x. 5x, 2x, 7x. 2 times 5. So sometimes the logical method, some of you are going to start seeing it. The only way you're going to start seeing it is by practicing it. You take it home and go, I don't understand this, and you give up. You're not being helpful to yourself. Number 9. What do you think? Can I do it the logical way? What do you think? Both signs have to be positive. Do you agree? What's gonna work to? Yeah, x plus 3, x plus 3. This one just factors to this. Like, but I don't see it that way. Okay. 9 times 1 is 9. Both have to be positive. 1 and 9, 3 and 3. Which of those add up to 6? 3 and 3. So then I have x squared plus 3x plus 3x plus 9. X, and that's x plus 3. Positive 3. X plus 3. Is this the same as that answer?
Yeah, buddy.
Okay? So again, the more you practice these, the better you become. If you are the student that it went home with you, stayed in your bag, no application went to it, because I'm just going to copy off my friend when I get to class tomorrow, can't tell you that that's a good, formidable way of doing math. You know what I should be really good at? I should be really good at. If I could just watch and get good at it, I should be an awesome football player. I should be incredible. I should be able to have a game like Tom Brady and not even cheat.
Wait, I don't get it.
He didn't cheat in this game. But
In this game.
he got caught different scenarios over the past few years. He kind of was bending rules. I'll just say that.
Cheating.
But am I as good of a quarterback as he? No. I can't even throw overarm like this any longer because I got a partial tear in my shoulder. I can sidearm it, but I can't throw this way. I have no strength to throw over. But just by watching, like some of you are doing, should make you really good at it. And then when you try and do it, going, this is hard. Yeah, because you're just watching. You're not applying the thought process. Okay, so if you start applying the thought process to this, ladies and gentlemen, I promise you it's going to get easier to do. Okay, so page 3536. Page 3536. And I'd say skip 17 and 18. That's what I got for you. Sound good?
Yes.